Okay, I got a couple minutes to make this video. Hopefully I can get it in. I did some writing in red, and so we don't get confused, I'll go with some purple here. So a uniform distribution takes place when every outcome has an equal chance of happening, or a uniform chance of occurring. So think of dice. Every single side of the dice has a 1 in 6 chance of occurring. And in that case, in general, the probability of X occurring if there's n outcomes is 1 over n. So if there are, the probability, let's word that now with dice, the probability of the number 3 occurring, or the probability of any number occurring, is 1 over the number of sides of dice, on the dice, right? So if the dice has 6 sides, we have a 1 in 6 chance of each of these occurring. Okay, and let's quickly figure out what a histogram would look like first before we do that. If we look at a histogram, all of these are going to have a 1 in 6 chance. If that's 1, it's going to happen 1 out of 6 times, and 2 is going to happen 1 out of 6 times, and 3. And it's always going to be 1 over n chance, or probability of it occurring. But the way you know it's uniform is all of these bars are the same height. Okay, and then if we're going to look at the expected value, you can do what we did here. You can still do what we did the other day. You take your x and multiply the probability of x and find out xpx, and do that all the way through and add them up, and then you end up with 3.5. So when you roll a die, a 6-sided die, and you go and you try that, on average, you're going to get a value of 3.5, which of course can happen, but it's still the average. So let's just talk about the 3 different methods to find expected value. One is to do what we did right there, is x times p at x, and you're just going to sum all those up from 1, x equals 1, all the way to 6. So for each of those, you're going to go, I have a 1 will come up 1/6 time, and I'm going to add to that how often 2 comes up 1/6 time, and all the way through. Okay. Another way to do it is to say, look, everything happens 1/6 time, and the outcomes are 1 and 2 and 3 and 4 and 5 and 6. And what you can do here is you can add them up first and multiply by the common frequency. You can only do this with the uniform distribution, because that's the only time where each of these has the same chance of occurring. Another way to think of this is if you expand this 1/6 all the way through, you end up getting the exact same numbers that we have up here. You have 1/6, 2/6, 3/6, 4/6, 5/6, and 6/6. Okay, and when you add them up, you're still going to get 3.5. And the third way is really just kind of an expansion of what we had earlier here, is if you're going to add up the numbers 1, 2, 3, 4, and 5, and 6, right? One way to do that is to use this formula here. And this formula is generated by doing this. You take the first number and the last number, and you make a pair, and that adds up to 7. So if you take the first number and the last number, you get 7. And if you realize you have a bunch of pairs that add up to 7, the first and the last, this and that, and as you get closer and closer, the difference gets closer to each other, but the total still stays the same. It's still n plus 1. And then you ask yourself, how many pairs of these do you have? Well, in this case, we have 3, and in general, you have n divided by 2 number of pairs. So that's one way to do that. Take the first and the last, add them together, multiply by n, and divide by 2 to figure out the total. You don't need to do this. And if you do that, though, you're still going to multiply by 1/6 and get 3.5. Okay, the last thing I want to look at in this section right here is what a fair game is all about. A fair game, when you do all this, I'm running out of time, but when you do all this, your EX is equal to 0. A fair game means that when money goes in, or a value goes in, a value comes out of the same size. So this is not what you're going to find when you play games in casinos, right? Because in casinos, you're going to lose money. But if there was a truly fair game, if you include how much you paid for something, and you played it over a long period of time, it's what we call a fair game, or a zero-sum game. Kind of, that's a different term, but it's almost the same thing. Is when, on average, nobody wins and nobody loses. Everybody's a not loser and not winner. Okay, I don't know if that's an expression. I just made it up. Okay, but in general, what happens is the expected value is 0. So how do you figure this out? If a game is fair, you go through it and find out the expected value. Okay, you find out the expected value, and the expected value, that's an E, not a sigma. And if the expected value is 0, then it's a fair game. Okay, hope that made sense. Take care.